here's a sore site that often gets overlooked with the good old Nema 10-30R. This screw here, the silver metallic screw, is for your white wire. And it says so right here. I don't know if you can see that, but it's kind of upside down, but it says white. And then your hot wires would go here for your 220 volt. Sometimes I see these boxes and they leave out the ground. Well, these things really shouldn't go in a plastic box. And the reason for that is because unless this plate here is made out of plastic, there's no ground here. Just say one of these wires were to come loose for one reason or another. If you get this wire loose and it just happens to come out, and well, think you're slick because you put a plastic plate over it. Well, the screws are not plastic, so yeah, this standalone ground wire might be put to good use if you ground the steel here by using maybe a grounding clip. Here's another scenario where you might think you're doing good because you pulled out the red tape and you're marking the white wire as a hot, but you're using the ground wire where the neutral is supposed to go. And now you have no way of grounding your metal plate there. These old receptacles were never really designed for a plastic box. Its true nature and intention was designed for steel boxes, grounded steel boxes. And that's exactly what you see here, where you would use a 3 conductor cable with a ground, and you would run your ground to the steel and then use your white accordingly as your neutral and your two hots. So that way the steel's grounded. Not only that, this steel is grounded, and if you ever put a raised cover or a mud ring, those also too would be grounded. So if this steel was making contact with this mud ring, that would be grounded, and so will the device that would be sitting on the mud ring would also be grounded, and there wouldn't be any need to use these little grounding clips. If you have a 3-prong setup with 4 wires coming into the box, keep in mind that the dedicated ground only reaches to ground the steel and not the dryer. These receptacles are prohibited in new installations, but they still circulate into people's homes. By default, the neutral is bonded to the dryer's metal frame to offer protection for those who still have this old configuration. For those who wonder, here's the neutral jumper cable, and here's the steel frame. Still wondering? Let's have a close look at this. There's that jumper wire bonded to the neutral. And we're at 495, 478 millivolts. You wouldn't jump a wire from the neutral to the ground screw on your regular receptacle, so with some forethought, they came up with a solution to remediate the idea of having the neutral bonding jumper on the dryer's frame. It's the Nema 14-30. And not only that, they're plastic box friendly. Let's just have a close look at it. And as you can see in the back here, there's green for ground, and it has this little clip here that actually attaches to the steel, and just like that would be it. If you look at the RV one, which is the TT-30R, you flip it over, you also notice that there's a green screw and a clip for ground. The reason why this outlet does not have a clip for the ground is because this is meant for neutral. And as you can see in the faces here, these U-shaped hole here is your ground. That's your ground up here, that U-shaped hole. This is not a ground. There is no U-shaped hole in this device here. With 4 wires in place, and using the Nema 14-30 receptacle, along with its corresponding 4-prong power cord, would be better executed. It's more organized since you have your dedicated ground and your dedicated neutral. If you're using a 3-prong power cord, do not ever remove the jumper wire from the ground screw. It is forbidden. Only for the 4-prong power cord, remove the neutral jumper and place it on the terminal block's neutral terminal. The intention of the 4-prong power cord is to settle an old argument where neutral and ground should be bonded at the main panel and not the dryer. So if you come across one of these in a plastic box and there's a ground wire doing nothing, it might be a good idea to have it removed and put one of these in there, even if you do have a main panel. The same holds true for these old light switches. They were attached to a steel box. They had no ground screw on them because the steel box was supposed to be grounded. Ever since they came up with these plastic boxes, they started assigning ground screws to the light switches and receptacles. So do not put these old light switches in these plastic boxes. There's also a surface mount option, and this dryer outlet, it's nice if you want to replace it because the sockets are worn. Just need to do a quick little service and just replace the box totally. It's nice that they sell these. If you have an old 3-prong dryer outlet with the 10-2 wire and you're in a pinch, a replacement of the same outlet, the same dryer outlet, would be allowed. If you have the means, have it replaced with 10-3 and get yourself a 4-prong dryer outlet. With all of the arc fault and GFCI breaker requirements, this 3-prong setup will trip those new breakers every time. On the other hand, with this 4-prong setup, things will run smoothly since the equipment ground and the neutral are separated here, as they should be configured to be correctly separated on the dryer's terminal block. Even if you think you're using the bare copper as your equipment grounding conductor, when plugged in, this power cord center prong will serve as a grounded neutral when the dryer starts turning, causing the bare copper to act as a grounded neutral. If you think about the SEU and how it doesn't have a sleeved neutral, I bet they thought that they could get away with the idea of running this 10-2 with a bare ground to be used as an unsleeved neutral. It even says here, caution, this device is not for grounding use. The way I see it, I'd go 4-prong. That way you can get your GFI set up into it, or whatever they may come up with. Remove cover, strip 6-inch of sheathing off the cable. This is the cable that I have here. It says here that my hot wire goes on the left and my other hot wire goes on the right here. But the middle here says that it's the neutral white wire. Okay, it doesn't say anything about a ground here. And I did just that. So if you look here, I have my white wire and then my 2 hots on the side here. And my ground is just left to do nothing. Whereas if I get a 10-2 cable and I apply it here, I would kind of be forcing that white wire to be hot and my ground to go in the middle here where the neutral goes, which is not my white wire. Not only that, it doesn't have a jacket on there, which is no different than the dryer having neutral all over it when you wire this thing. What about this steel? What's going on with that steel? I mean, it's not grounded. And it's a bit of a concern. Even though this has a plastic cover, there is still steel on the side here that I can come into contact with. So if I don't tighten these screws good enough, for example, or if I don't torque them to specs, like it says here, to do 35 inch-pounds, or I over tighten them and this wire starts to burn and it touches the steel here. Now either this steel becomes live and it doesn't trip the breaker, or it can just keep working its way down. So if I'm required to ground this steel, why am I not required to ground that steel? I think this is a very old box. It's a complete mess, whichever way you put it. It was intended to have conduit coming through it, or some sort of armored cable, some metal conduit or armored cable. So what I've decided to do is I decided to ground this steel here. I'm gonna get this tapping tool and just tap that all the way down to a 10x32. Now, according to the instructions, you're not required to do that, but I like to play it safe. I'm going to get this ground wire in the right direction. Just going to make that hole. But really though, why bother? Just go for a prong. I hope you like this video. Comment, subscribe, hit the bell, and I'll keep making more content for you. Thanks for watching, and until next time.